Hey everybody, this is Luke Parisi. I'm doing a video on the 3D engine I've been working on. I didn't put out a video last week as I went and did work on Battle Court and got a new update for that out and did the trailer. So I haven't touched this past week. I haven't touched this game. All the work I'm going to show this week was what I was going to show last week, but I thought maybe I'd come back to it and have more to show, but yeah, I went to work on Battle Court. So there's only 3 things to show. One of them is this miner. If you look at the center of the screen with that cursor, if you remember from the last videos, that cursor had a slight movement. I've just fixed that and that was pretty easy. I just made sure to set the position back to half screen width and height, with adjustments to the width and height of the image itself, so that perfectly, actually no, I'm using the top left for its origin position. So yeah, that's all I'm doing for that, just resetting it before updating the draw. And the other thing was I worked on the collisions, a lot more work on the collisions, mainly with getting this collision on OBB wall slide working nicely. I've since removed the multi-wall collision again because I need to change that to work for OBB collision as well, because what I had set up was just for axis aligned multi-wall collisions, and when it was oriented bounding box it wouldn't work at all. So that was one thing. I still have a bit to do. And the other thing was the prefabs. So the prefabs are now working across all rotations. So as you see, the placement of all these walls and that door. So yeah, with this gap I just have to fix the placement of this wall. But the placement is exactly the same on this, which is the exact same prefab on just a different rotation. So everything placed nicely. And this one here I won't walk over to, but that's the exact same prefab, just rotated 90 degrees. So a few of the issues with the rotation was initially the wall placement wasn't correct, so I had to make sure I calculated the new current position correctly based on the rotation. So obviously on a 0 rotation placement, we can just say, like say this here is the initial position, this one here, and then let's say we place a wall, then we know, alright, we can just get the wall's width, and then place the next object based on that width, and then get this object's width and so on. But you can't really do it when there's a rotation, especially like even this 90 degrees rotation. We can't say the wall's width, because then it would place the next object. So this is, yeah, rotated 90 degrees. It would think the wall is facing from along this. So it would place this wall here, and then the next wall would be placed here, even though it had the right rotation. So we need to calculate the next position it places the walls. So again, same with, oriented bounding box. So that was one issue. The other issue was the doors. So I wasn't actually getting the start rotation to calculate the open and close positions. But that's fixed. And as well, the door wasn't placing correctly, and it was moving over here on the initial open close as well. So that's all fixed now. And the next thing I wanted to get done before making this video was this multi-wall collision across all rotations, but as I said, I went to Battle Court and did all that and made the trailer for that. So at the moment the multi-wall collision isn't in again. But the wall slide is working really nicely. And that were the main things anyway, getting the prefabs. So not much, as you see, cursor position, prefabs based on rotation, and a wall glide. So I'll go into the code. I'll start with the prefabs first. So with the prefabs, just give me a minute and I'll just close the door. So now with the prefabs, if you've seen from last video, I was passing in only the prefab type and the start position, but now I'm also passing in start rotation, and yeah, pretty self-explanatory as to why, but you pass in the rotation and then we can pass in those rotation to any new models we add to that prefab. So here you can see adding the model with that start position, plus on this here, this vector is just adjusting for the height to make sure that the height of the objects are level. So this is getting the model dimensions y divided by 2 and placing it based on that. So it's adding the height to that. Because when you pass in start position, you're pretty much passing in in this case I pass in the bottom left or the bottom right corner. And on the Z, the closest to you. Anyway, so that's the model, and then we add to grid, and then with the current position, if you saw in last video, I was just incrementing the current position based on the model's dimensions, because what that was with 0 rotation, but we don't want that. So now I've added these methods, the calculate rotation position. I run that twice. First time I run it is against the model that you just added. So here, this is the model here that I just added, the stone wall, and then I run it again on the next model that I'm going to add. So for this, I add a wall, and then the next one I'm going to add is a door. So I just pass in a calculation on that, the dimensions of that, x divided by 2, so the width, half of the width, and then the next one's going to be a door, so I want to increment that position by half of the door's width as well. So yeah, and I'm using x here instead of say the z, because how I've done these models at 0 rotation, they're facing longways. So like if the wall was facing lengthwise, say you have a model that you've initially rotated at 90 degrees when you created the model, then you would want to use the z-axis. But this is stuff you probably would know about your models anyway. So like that's why I'm using the x here. So all my models are along that width. So this is the method itself, and that's that exact same rotation position calculation that I use in the bullets in whatever, going back to Lords of Delusia with the bullet creation. It's that same x times cosine angle minus z or y, whatever you're second. So as you see here, I'm passing in the current position. So let's say we just placed the wall. Current position you passed in would still be that initial 0, 0, 0. Previous position gets set to that. Let's say we have start rotation 45 degrees. We know the width of the object. I mean, this probably isn't the best naming convention here, object width. This could be object Z as well, so object dimension. And then all we do is we're passing that into the X. Z, we're not using any, so X object width Z, and then we're calculating the rotation position which is so this here, return new vector 3 plus xz, x and y, this is the update to the current position based on that object's rotation. So object width is that wall, so we're getting half that width. So by calling calc rotation position the first time, we're moving, I'll get up paint again so I can draw it. Paint. So on that first, where's my mouse? So on that first, so let's say we have this rotation, that's the wall. And then let's do a different color for the door. And then we'll say, why did it change again? That's the door, that's wall 2. So initial point is here, and then if it was 0 rotation, we can just say, you know, get wall's dimensions and move the current position to there, which is not what we want. But what I'm doing by doing it twice, I am getting, I actually think current position, no, I'm pretty sure it's still the bottom right. But what I'm doing by getting half is calculating rotation position based on half. So it actually has to be in the middle, I'm pretty sure, based on what I was doing. So initial point is the middle, is the center of the object. And then by getting half it is the center of the object. My initial positions are always the center of the object. And then by doing the first calc rotation of half the model's width from here would be, so it calculates to this point. But if we only run that and draw the door would be passing halfway through this wall here. So then I run a second calculation on the next model I'm going to do, which is the door, and then do a calc position on that door, which then gives the center point for the door, and then the door gets placed at that point there, and then the exact same for the next. So from the door we do a calc rotation check, which gives us the result of this on the X. So this is top down, by the way, if that's not obvious. So then it places with the first calc rotation, which is this one, we get the model stone door, which places it there. Then the second calc rotation position, we have half the wall's model width, which calculates the position there. So that's that whole process there. If you already know, object rotation position calculations which get used a lot, then yeah. But that's the main formula. And I've used it heaps in all my games. Lords of Delusion, Battle Court to get the bullet start positions. In this, I've used it in a bunch of places. So that's how I'm getting the correct positions of the model placements for the prefabs when they're rotated. So that's along. Then here, I'm placing 3 walls. So what I'm doing here, I'm only running it once and using the entire. So if I know the object that you just placed and the next object are the same, you can just use the dimensions, the full dimensions X, because you're pretty much moving halfway of the first one and then halfway of the second one, which is the whole of, if they're both the same, then it's just the whole. So that's the prefabs now with the rotation. There was changes I made to, I think, to the model render. I need to look at that because I can't remember. Because to adjust the door, that was the main reason, was the door was playing up. Rotate with position, I think this was what I adjusted. I can't remember even if this was in the last video. Yeah, it would have been. But this I would have adjusted if I did. I think I added that rotation position calculation as well. But or maybe it was in door open and closed states. Yeah, I think I added this start rotation, or if that was already in, I fixed it to work properly. But that, I just made some adjustments here to the model, if it was open and closed, so it wasn't getting that initial rotation right. So start rotation is the rotation that the door starts in. So when, let's say we call it in prefab and we do this when we add this model in the constructor, we're setting both the rotation and the start rotation now with that initial rotation, and this never changes. So that's only, at the moment, only for the doors, so we know where the door state closed should go back to. And I just can't remember if I had done any changes to this. If I did, I think it would have been this, where I added the position calculation updates based on no. Yeah, I'm pretty sure this would be new, because position no rotation would be again like that start rotation. So here, because what was happening when I rotated the object, and let's say, so here I'm getting the initial position and basing the new positions off that no rotation position, because what I was doing when I did this, when I first did this, I was passing in position, and position gets updated by this formula. So it would run the door every frame, the door would open a bit, position would get updated based on where it should be, and then if I passed in that new position, then it wouldn't calculate correctly, because that position itself had changed. So to base the new position off the changed position, it would just generate the wrong results. So with this, always base it off a static no rotation position, and the same with that rotation, or with the door open and close states. You want to base the start rotation off it as well, so that you know when you close the door, it goes back to, you can't go through that start rotation as well. So here, because obviously without this, what are you going to say rotation Y? If let's say we know it's always going to be a zero rotation, then yeah, you don't really need this. But without this, you would say what, like 0 and 90 degrees, right? And that's if you know that it's gonna always be at a rotation 0. But if you want to have doors that have a rotation, an initial rotation, then you have to add that to your states, open and closed. So that was the doors. Now the collision, I'm pretty sure it was this that I made changes to. Handle vertical. So I just need to have a quick read again because there were so many different ways I tried to go about it. So if the model is rotatable, I'm doing the MXC as well. I thought I changed that, but so what I'm doing is similar to the ramps, and that was, except instead of the ramps, which are the X and Y, I'm doing it so rise over run for the ramps is, you know, X position and Y position, but rise over run for walls would be Z. Z would be the rise and run would be the X. And then C is the Z position, and X is simply where that model is on the X. So the cam position, which is your current position minus. So that's that exact same formula I was doing for the ramps, MX plus C, and then yeah, above and below is just the same. So this is if you're on top of the wall or below the wall, and then yeah, I remember not using this, and I'm pretty sure I'm not. So, hang on, yeah, I'm not. That's right, because I remember I wasn't using this. That was the first thing I tried, and it wasn't smooth, so I'm not using this. And yeah, I've gone for this. So what I've done here, which is a lot better than doing rise over run, I'm getting a scalar, which is the vector dot product of your current move vector and the model's right. So these I've added to the OBB. It's just a rename of the so this in the last videos was an array of vectors. So I've just named them to be more readable. So here you could see upper top left, lower top right, and so on. And here I'm also getting the normals. So the front normal is the, I'll draw. So when you hear most about a model's normal, you would mainly hear about it as so let's say that's the wall. You would hear about the normal being that vector outward. So in this case here, I've got 4 normals, and this would be the front normal. So this here is just the cross product of AC and AB. AC is the upper bottom left and the lower bottom left. So all these naming conventions are from looking top down. So upper, bottom, left means the upper plane looking top down, and it's the bottom left. So looking top down, if we so if this is top down, that's this here, upper plane, bottom left, and then upper plane, bottom right. That's our AB, and then AC is, I won't be able to draw it top down, but it's this one here on the top, and then the exact same position at the bottom of that model. And then we just get those two vectors, and we're getting the cross product of those two vectors, and then normalize, and that gives us this front normal here, which is the arrow shooting outward. The back is the same, but we're doing it like this. So that's the back normal, and then the left normal. So if you don't know, back normal is like the opposite. So I'm getting upper top right and upper top left vertexes, and upper top right and minus upper top left is AB, and then upper top right minus lower top right is AC, and then cross product of them to get the back normal. So when you're calculating your normals, you're getting the cross products of let's say the dimensions of that plane you want to get the normal of. So if this was a 2D object, and I'll draw this from front on, right? So this is you're looking at the wall from front perspective. I just hit the mic. But this is to calculate the normal, you're getting the two axes, or the two not axes, but the vectors from each point here. So we're getting this point to this point, we're calculating a vector, and then we're also getting another vector from this point to this point, and then we're doing a cross product of those two vectors, which will get a vector that's at a right angle to both of those vectors. So it would, imagine it would be like this. From here, from this perspective, it would shoot outside of the screen. So that's the vector cross product there. So, and that's here, that's calculating the front normal here. So to calculate the back, you would do the same, but you would start from this position instead of this position here. So you do the exact same. So you'd have this to this, and then this to the bottom plane of that same position, or the bottom bottom vertex of that same plane there, and that would calculate this normal. I'm not the best at explaining things, I know, but yeah. I hope it's decent explanation. So how would you do the right then? So right would be this here, not the arrow. Right would be from the top here to the top here, and then that would be your first vector. Your second vector would be the top here to the bottom here, and that would be your second vector, and then you'd get the cross products of those two vectors, which would, it's kind of like looking at this again, but from, you're standing here, This is where you're standing and you're looking at this wall here. So that's kind of like the side of the wall that you're looking at, and it's always that exact same calculation. You get those two vectors, and then you get the cross product of those two vectors to calculate the normal. And normalize is just turning it into a unit vector with that same 3-axis rotation there. So I'm getting those 4 normals there: front, back, left, and right. I've got them all. I don't think you even need all 4, but at the moment I've just done it just so I have it there. So going back is I'm getting the scalar. So vector dot products always return a scalar. Now why I'm getting a scalar is because that will be your move speed in a sense. So here I'm getting the dot product of your current move vector and the right normal, which is a right normal is always going to be like if that was a scalar, that would be 1, yeah. Anyway, so getting the dot product of those, and then this vector is equal to the move scalar times the right normal, and then the y remains the same. And this means that when you jump, you don't get stuck, you keep falling. And then I'm translating the camera along this new vector here. So here, so with this, it's so like, let's say this is a rotated wall. We're coming at this angle. We're getting the dot product of this vector with the normal. So this would be a vector like this. And then we are comparing that. We are timesing that. So this is a dot product. We're getting the dot product of these two vectors, which will return just a scalar. And that, so let's say we're going at this direction. When we get the dot product of these two, the scalar should be something like -1.2, let's say. But in this case, it would be a negative. If we were coming at this angle, the scalar would be a positive. And, oh man, relying on paint. So yeah, if we're coming at this angle, when we do the dot product of this vector, your current move vector, with the model right, then the scalar would be like +2, let's say. But in this case, we would have, -1.3, right? So we get this final vector, which is relevant. So it's based on the right normal. So we're getting a scalar of this right normal here. So if it's this normal multiplied by -3, then what would be happening is the result vector would be in this direction here. So when we collide with the wall, we're going from this move vector to do those calculations, and the result vector is a scalar based on this right normal, which is moving you in this direction now. So if I bring that up again, bit choppy, but so as you see in that example, we hit that, and then that move scalar, I'll do it on the rotated because that's where I'm actually doing those calculations. So we hit it at this, and then that result vector that you move is based on that right normal. Actually, I'll quickly just set it to scene. Window capture. There we go. So, and if we hit it straight on, then what's your result vector? Well, 0. The scalar is 0. So right normal is shooting in this direction. If we come at that, it's that vector dot product with so it's my move vector, which is in this direction, dot product with the right normal of this wall, which is shooting in that direction. In that case, we get a negative, so our result vector is resulting in that direction, as you see. And as you see here, doesn't work on the sides, but it works on the back. So yeah, that's kind of a compromise at the moment. It's not working on the sides. Even though I thought it was, from what I remember, I thought it was, but maybe it was from this angle here. No. Yeah, so it's not working from the sides, but that's why I've got this here. So as you see, the multi-wall collision. So that's one last thing to fix. But yeah, that's how you do proper collision with OBBs if you want that slide without a bounce. So as you see there, there's no bounce or anything. It's just that result vector is a scalar of the wall's right vector there. So that's what I spent most of my time on 2 weeks ago, is getting all that right. And yeah, then I was gonna get all the remaining things with collision, so like that wall being able to pass through the thin side, and fixing the prefab gen on the other wall. But they were the main things. So yeah, not much. But yeah, for now I'll leave this video at that. I'm not sure if I'm going to put out another video next week, because I'm holding off on doing any work until I get some information on some stuff that's happening in the next week or two, which I don't really want to talk about on video. But yeah, so there might not be a video out next week, but if I do get a chance to work on this stuff, I will definitely do so. So yeah, I'll leave this video at that, and thanks for watching, guys.